Hello, and welcome to 6.2/64 Applications of Trigonometry. In this particular lesson, we are going to do a lot of pretty much word problems. This lesson, kind of combination lesson. And first and foremost, we're going to talk about angle of elevation. Now, angle of elevation versus angle of depression are two very similar but slightly different things. Imagine, if you will, let's draw you, are standing, across the room from, let's say, Shaquille O'Neal. Shaquille O'Neal is probably a lot taller than you. And when you're talking about angle of elevation versus angle of depression, you want to consider your horizontal line of sight. Meaning, let's say you are looking straight. And actually, let's do this. Let's do a straight line. Straight line across towards Shaquille O'Neal. So let's say this is you. Let's do it in the actual color. You versus Shaq. Now, if you're looking straight at him, you're probably looking at his arms in this particular diagram. Versus Shaq, if he's looking straight across towards you, his line of sight, let's do this in the highlighter, is way over your head. Okay, so this is your horizontal line of sight. Angle of elevation depends on in which direction you kind of tilt your head up or down. In this particular case, you are looking up to see Shaquille O'Neal, unless by some miracle you are taller than Shaq. In Shaq's case, he is looking down to see you. So if you two made eye contact with each other, you would make that line that's directly in the middle here, this line. So if you're having a staring contest with Shaq, it creates the angle of elevation for you. So that's what this is right here. Let's do this in purple. This angle is an angle of elevation because your eyesight, your head tilts upwards, versus Shaq's eyesight goes from the line downward. So this is the angle of depression because his eyesight is going down. So those are two very, very subtle things with each other that are related to each other because, ironically enough, these angles are congruent to each other. If you remember from geometry, if you have a set of parallel lines and you have a transversal, these two angles, elevation and depression, are alternate interior angles. They are congruent. So in this diagram, we could say angle of elevation is congruent to the angle of depression. And that is kind of the big takeaways, that they are actually congruent to each other. So, knowing that, your head tilts up to see him, angle of elevation. Shaq's head tilts down to see him, angle of depression. Knowing that, we could actually use this concept, this term, to do a whole bunch of trig problems. So for instance, a plane, and whenever you're doing word problems, I highly recommend that you draw a picture. So in this first example, a plane is preparing to land so let's draw a plane. A plane is beginning to land from a height of 10,000 feet. So we have a height of 10,000 feet at an angle of depression of 10 degrees. So what this means is if we have a line of sight, and let's do, for instance, blue, their natural line of sight is going straight across, but their angle of depression is going down 10 degrees. You could do this one of two ways. The line of sight from the line of sight to the angle. That is this angle. This is your angle of depression. And this is 10 degrees. So we could do this problem two different ways. So if I proceed that this is the ground, we could say, let's do this. What is the distance traveled from the line of sight? What is the distance traveled So this is the distance traveled, is the hypotenuse. That is the total distance that particular plane is going to travel from the air to the ground. And that's why I say line of sight, from the, not the horizontal line of sight, but the actual line of sight to the ground. What is that distance? We could do this problem one of two different ways. We could always make a right triangle with this blue triangle here and put a right angle here, and we could solve for this, because if you realize this distance and this blue line that I just drew is also 10,000 feet, because if that plane flew straight forward, it would still be at 10,000 feet. Or what we could also do, let's do this in red, is we could translate this angle of depression down to the angle of elevation, because if you're looking at the ground up at the plane, that's the angle of elevation, and as we just said, these angles are congruent, so we could say this is 10 degrees. Now, however you want to do this problem, it's up to you. Ultimately, we are solving for this length, the hypotenuse. So considering that, I'm going to use this particular one, this triangle, the black one. The 10,000 feet is the opposite side. The hypotenuse is the hypotenuse, and we would need to use sine here. Ironically enough, it'd be the same thing here. 10,000 feet is the opposite side. Hypotenuse is still the hypotenuse. What is that distance? We have 10 degrees. So this is what we need to do. We need to use, which trig function involves opposite and hypotenuse? That's sine. So we have sine of 10 degrees, because that's the angle we actually are using. We have opposite side, which is 10,000. And we have the hypotenuse, which we don't know. So we could call that, for instance, h. And we could just start solving. If we want to do this, we absolutely could. H times the sine of 10 is equal to 10,000. Divide both sides by sine of 10. Sine of 10's cancel out. We get h is equal to, and then this is where your calculator kicks in, 10,000 divided by sine of 10 degrees. 57,587.7. 57,587.7 feet traveled. All right. Let's double check. 57,587.7. Good. So, assuming you're rounding to the hundredths. So there you have it. Angle depression problem where we're solving for the hypotenuse. Example 2. You are standing 6 feet away from a 40-foot flagpole, and assuming this is a 40-foot taller than you, because we want to kind of neglect your height. And if you notice, it says ignore your height in this problem. Looking up at the flagpole, what is the angle of elevation? So let's take a look. Here you are. Here's the flagpole. And remember, it's 40 feet taller than you. So this is the reason why, because we kind of want to ignore your height. We ignore that. And this distance is 40 feet. We know you're 6 feet away. What is the angle of elevation? So from the natural line, the horizontal line of sight, looking up at the flagpole, we have a right triangle. And here, if you want to redraw it, you absolutely could. Right angle, 40 feet, 6 feet. And we should solve. We want this angle. So we are solving using the opposite side and the adjacent side, which is tangent. Tangent theta is equal to 40, that doesn't look like a 4, 40 over 6. Now, if you remember from inverse trig in our last lesson, we need to get the theta by itself, because we need to solve for the angle. So we need to do inverse trig. Anytime we're solving for an angle, we use inverse trig. So we do tangent, let me get rid of this. Inverse tangent, I should say. Open the parentheses, close the parentheses, throw this fraction in there. Inverse tangent and tangent cancel. We get theta is then equal to, And then here's where a handy dandy calculator kicks in. 40 divided by 6 is then equal to 0.11. Oh, that's tangent. There you go. That's why it seemed wrong. Inverse tangent is equal to 40 divided by 6 is equal to 81.46. Let's round that up. 81.5. 81.5 degrees. That is the angle in which we are looking up at that flagpole. All right. So those are the only two practice problems I have for the day. If you have any questions, please ask, and just be ready to get to work on a whole bunch of applications for these types of problems, trig problems, whether it's solving for a side or solving for an angle. All right, I'll see you in the next one. Bye.